Hello everybody, my name is Ryan Winder and this is my single axis gimbal for the final project. Now if you're wondering what a gimbal is, it's basically something that stabilizes video footage. You put your phone into it or a GoPro into it when you go out on a hike or riding a bike, and it makes it so the footage isn't so bumpy and jumpy. This project proved to be a lot more challenging than I had anticipated, but this is what I came up with. Alright, let me show you its features. So the idea is that the servo will have two different modes. One mode, it won't be stabilizing, so that it's free to rotate as it needs, and the other mode is it will stabilize based on the rotation. So the first thing that I'll do is I'll push this button right here, and the screen will say that I'm in stabilizing mode. And once it's in stabilizing mode, this accelerometer will start taking angle data and send it to the Arduino, which is right in here. And based on that angular data, this servo will activate depending on the error, how far away it is from the angle that I want it to be, which is in this case is 0. So the servo will activate and rotate it back into place so that the phone will stay level. Now, this servo, the joint here is concentric with this joint right here, so that they are able to rotate on the same exact axis. And also there is this power supply back here. It's just 2 batteries, and the power supply supplies the Arduino and the servo separately, because I didn't want to power the servo through the Arduino. I didn't want to mess up the Arduino at all, because it takes some more current. The one thing that I found really challenging about this was there's a lot of hardware, and how am I going to put it into a really compact handheld device, but also hide all of the wires. And so that was pretty challenging. And it made it so that this phone couldn't rotate as well as I expected it would be able to, because these wires don't slide in and out. There needs to be some slack here in order for the phone to rotate pretty well, because these aren't loose wires. They're the stiff ones that you can bend into place. And so that was one of the challenges I discovered as I was assembling this. So now we're going to do a demonstration. So I'm going to reach in here and turn on the power supply. Turns on the LCD screen. Press button to stabilize. So we press the button. And now the servo's active. It says stabilizing. So now we can rotate it a little bit, and depending on that angular data, the servo reacts to it. Whoop. And then you press it again just to turn it off, and hold it at whatever angle you want. One of the things that I learned from this project is that servos are not very good at high-speed feedback control. They have a little bit of a delay to them, which makes oscillation very common, and it makes PID tuning really difficult. I wouldn't say that they're very ideal for use in a stabilization setting. If I would have done things differently, I think I would have used a high-speed DC motor with a weighted flywheel, and use the inertia, the changing inertia of that wheel to stabilize it instead of a servo. So maybe for my next project I'll recreate it and see if I can make a better stabilization.